So for those of you who I don't met, my name is Simon Guest. I work at a company called New Desert. And I wanted to start the presentation by making the grand statement that the GPS is great. I'm sure everyone uses GPS for different various applications. But it's only great when you're outdoors. And of course, as soon as you walk into a building, as soon as you walk into a room like this one, indoor location is typically a very, very different story. And of course, GPS signal rarely works indoors. When it does, it's often very, very inaccurate because it's bouncing off all kinds of walls. And there's no real concept of indoor space. There's no concept of floors or zones or areas in an indoor environment. Now, we've had companies try to do NFC-based solutions where you use your phone or your device and you check into various places to identify where you are. And of course, we've even had properties to see if that works as well. And I'll be honest, it's a lot of very custom. Many require a lot of power, things running on the phone all of the time. Many are very unpredictable, and many don't even run in the background. So very low power consumption. Secondly, it offers what's called simple pairing. So I'm sure we've all run into problems with pairing a Bluetooth device. You've got to enter the PIN, and then you forgot it. With the Bluetooth Low Energy, the pairing is still secure. It uses a symmetric key, but it doesn't require anything on the behalf of the user. And certainly in terms of Bluetooth LE, we're seeing quite a wide range of support from different hardware vendors. So, kind of interesting, but how do iBeacons relate to this? Well, what Apple have done is they've created a specification and a trademark, and they've built on top of the Bluetooth LE spec specifically a specification that focuses on indoor proximity. So you can kind of think of this fairly similar to a Bluetooth profile, except whereas a Bluetooth for quite some time, and fairly low cost. So this particular device, the single unit cost is about $30, but certainly that cost is coming down very quickly, especially if you're ordering these in bulk. So what does this device do? How does it work? Well, when you provide power to this, you kind of see the LED on it. It's broadcasting a signal over Bluetooth LE, and that signal is typically a UUID, so a unique identifier. And that unique identifier kind of establishes a group of beacons. So you don't get a UUID for each beacon, you actually get one that's responsible for an entire group. So if I was a particular organization or a team and we were setting up a bunch of these, we would actually configure these beacons to be the same UUID. So it kind of identifies the group. Now, of course, we still need to identify these beacons uniquely, and that is done using two integer values called a major and a minor number. So when you configure these beacons, you give it the group ID, the group UUID, and then you set these two values, major and minor. And major could indicate maybe like a floor level. So maybe it's the floor number if you're, say, you're doing this in a hotel or something. And minor could be maybe the position on that floor. So it's just a way of categorizing and saying, okay, I found a beacon, and I've just got something unique that I can identify that with. Now, of course, once these beacons are transmitting, you can use other devices to pick them up. So devices nearby these beacons can search for a particular UUID. This searching is known as a ranging. So if you ever see the term ranging, just means searching. And essentially, any device within a certain proximity will be able to pick up different types of beacons. You might be wondering what the range of beacons typically are. So in an indoor, unobstructed location, so with no walls, you're probably going to get around 100 feet maximum. So again, it varies depending on conditions, but certainly with customers that we've used, we've used beacons with, that tends to be the norm. Now, once a device finds a beacon, it can determine the power level. So it's picked up a signal of a beacon, it's saying, okay, I've got a particular power level, and that power level can be extrapolated or equated to a particular distance. So depending on what power range or power level the device has found the beacon at, it can say, well, I think you're 100 feet away, or I think you're really, really close next to it. And if you look at the Apple API, they provide an integer for the power level, but then they also provide 3 enumerations. So they provide something called immediate, which is typically within about 3 feet of a beacon, near, which is typically around 3 to 10 feet of a beacon, and then far, which normally means anything between 10 feet and infinity. And this is kind of nice because as a developer, it gives you the flexibility of looking at beacons from a distance perspective, but then also having an enumeration where you can just say, okay, just tell me the one that's right next to the phone. And as you can probably imagine, there's many different scenarios for how customers and organizations are running beacons today. We've been doing a lot of work with retail customers, putting beacons in stores, so to help customers find and locate different products and aisles. Education, I was down in Mysore last weekend, and I was going around Mysore Palace. And I was like, wow, if we could just put beacons around here, then I could take my phone out and I could find the closest beacon and it could tell me about what statue or what thing I'm seeing. Oil and gas, we're actually working with an oil and gas company in America doing their safety. So determining if there was an event on a gas rig, okay, where are all my personnel? That's critical information for that. And then even real estate. So if you're looking to buy a house, going in with your device and then finding out information about the house based on beacons is something that I think has a lot of opportunity. Now, I think with all this, however, it's really key to remember that iBeacons are not smart. They're actually fairly dumb devices. They don't have network connectivity, they don't connect to Wi-Fi, they don't have cell, they have no concept of the world around them. They don't know who's discovered them or who's in range. All they are responsible for in life is just sending out this signal over Bluetooth. And they just send out this ID, this major, and this minor version. So when you come across beacons, try not to think of them as smart devices. They really are just transmitters. So a good question is, okay, well, we've got some beacons around here. What devices can actually pick up these beacons? So here's a kind of the list here. So if you're going to pick this up on an iPhone, you're going to need to require an iPhone 4S or an iPad 3 and higher. Those two devices have BLE. And they have to be running iOS 7 or above. If you have Android, you're going to need Android 4.3 or higher. BLE was in API 17, which is 4.3. And this is a big and, it needs to be running kernel version 3.4, which is the underlying kernel on Android, just so you get that support. If you have a Mac and you have some Bluetooth or Bluetooth-enabled Mac, then as long as you're running Mavericks, you can also pick that up as beacon as well. And then if you actually are looking at beacons, then there's various vendors. This one, as I mentioned, is a Red Bear beacon. Radius have a great set of beacons that just plug into USB ports. And then Eskimo have these kind of weird ones with sticky things that you can kind of put anywhere. What I should also mention is if you are running it on iOS, you can also run the iPhone as a beacon as well. So not only can it pick up beacons, but it can actually act and behave as a beacon as well. So hopefully that gives you a quick overview of beacons and shows you kind of what they are and what they look like. I want to spend some time actually talking about what it takes to develop an application for a beacon. So in iOS, maybe a show of hands, how many people are iOS developers? Okay, good demo. So in iOS, support for iBeacons was added in a framework called Core Location in iOS 7 and upwards. And it's fairly simple to do. What you do is you create a new, what's called a CL beacon region. You give that beacon region a particular ID. And then what happens is once you start listening for beacons, there's an event called didRangeBeacons. And that event gets fired and returns an array of pretty much whatever it found. And that event probably around a second or one event fire per second. So you can kind of scan fairly quickly. And in terms of code, this is probably going to be unreadable on the slide, but I'll keep it in there, and we'll switch to the actual IDE shortly. But essentially, it's fairly simple. You configure your UID here. You've got your CL location manager, and then in an event called Start Listening for Beacons, all we're doing is we're just taking this event here, and then we get in the arguments pass back, we get an array of beacons that we can then iterate through. So Android is a slightly different story. As you can probably imagine, Apple don't release an Android SDK. Surprise, surprise. However, Radius Networks, a company that's been involved in doing a lot with Bluetooth and iBeacons, actually have an open source SDK that they published probably about 6 months ago. And again, this is fairly easy. Maybe a show of hands who's into Android development here. Wow, a lot more. Okay, so good number. So what you do with this is you take an activity, you extend it with something called an iBeacon consumer, and then you have two events that get fired on that activity. One is on iBeacon Service Connect, which basically says, okay, I'm ready and I can listen for iBeacons. And then there's a second event called Ranging Beacons in Region, which will give you an array of beacons every second or so. And again, this is fairly easy. We set up our group UUID here, as I mentioned earlier. In the constructor of the activity, we set up all of the details, and then we have these two events here. One that basically tells us that yes, we're ready and we can start detecting beacons, and then the second that gets fired with returning an event args, which actually contains the array of beacons. So probably rather than just spend time looking through code in PowerPoint, I want to see if we can switch to a demo and see if we can see some of this working. And I will admit the demo gods have been strong this morning, so we'll see whether this ends up working or not. All right, I think Wi-Fi has dropped, so let me... Okay, so I have my iPhone here. I apologize for the Android developers. All of the demos will be on my phone. We'll get through that. And what I've got here is I'm actually using Xamarin for the demos, and everything you see here can be done in native code as well. Just that we do a lot of work with Xamarin at Udesic, and it just so happened that this sample was kind of ready and easier to put through. So as you saw, hopefully you can see this from the font size. We have a very simple application here. It's going to start listening for beacons, and what it's going to do is once it detects any beacons, it's going to put it into a list object here, and then iterate through them, and then add them to an array. You can see we're extracting the major and minor version here. And then I've got a fairly simple UI on the back end that's actually just going to display that in a list. So on my phone here, let's open up the iBeacon Explorer. So we can see that we've got one beacon that we can find. It's called beacon 1.5, so that's the major and the minor version. And it is saying it's about half a meter away, which is not too bad. And then if we go really close, then we'll see it switches to immediate, and then far away, near, and then really far away. And you can see there's a bit of a lag, just in terms of picking up that signal, but it certainly is working. You can kind of see that. Imagine that if this was a grocery store or something, maybe I had a beacon over the milk aisle or something. I could actually go here, and maybe I had an app that's running on my phone. I could say, okay, well, I mean, it's going to hang, of course. I could say that once I came into the near range, then maybe I'd pop up an advert on my phone, which wouldn't be annoying at all, that says, hey, milk's on sale today, you want to buy it 2 for 1. So hopefully this gives you an idea. Let me also I've got one hidden down here. So I'm going to provide some power. This one's actually running off the coin cell battery. So now we've got, again, the same UID number, the same major number, 1, but now different minor numbers. So this is 1.5, I think, is the one over there. This is 1.4. And I've actually ordered this in terms of distance. So now I can walk across here. And we should see that those flip. And now, of course, we're showing the one that's closest. So fairly simple stuff, nothing too complex, but actually, hopefully what this proves is it's fairly easy using a device and some fairly cheap hardware to get some fairly accurate information in terms of where I am indoors, assuming that I've got a bunch of these around. So what did we see here? Well, fairly simple application using CL Location Manager to range for beacons. Relatively accurate line of sight proximity detection. There is a delay there, but once we're there, it kind of shows us. And then we've got those enumerated proximity levels of near, far, or immediate. So this hopefully shows you the basics. I think in the last kind of 20 minutes or so, I wanted to touch on, okay, well, where could this go? So obviously, just detecting one beacon is interesting and maybe doing something around that. But how could we actually push this forward? I think there's kind of 2 things that are really interesting in this area. Number 1 is the concept of running beacons in the background. So up until now, we've just had an app running on the phone, and certainly for a lot of environments, that's of only limited use. I mean, if every time I walk into the grocery store, I've got to open up my app, that's going to be probably not going to use that much. So one of the nice things is that background detection is getting much more mature. This was actually made on the iOS side. This was made possible in iOS 7.1, which was released only recently. So up until that, it was a bit of a hack, but now it's fully supported. And there's some changes that you need. And maybe I'll just flip to the code here and show you this. So what I've done is I've got this class called Beacon Ranger here, which is doing the ranging for beacons. Typically in iOS, I would invoke that from a view controller. However, in order to get this thing running in the background, I actually have to initialize it from my app delegate. So typically in app delegate, once the app's finished launching, I just create a new instance of this Beacon Ranger, start listing for beacons. And then there's actually one setting under in the plist. Find that. Here we go. Requires background modes. We just need to set the background modes correctly as well. And again, I'll share the link at the end of the session where all of this source code is. And the nice thing about this is, even when the application gets retired to the background, or even when the lock screen is done, it will still range for beacons, so that method will still be invoked. And then in Android, it's actually slightly easier. So the Radius SDK itself runs as a service in the background. So those events that get fired actually get fired as a service that you can subscribe to. And then really it's up to you as a developer how you choose to handle that. So obviously you probably want to do custom things on your on resume or on pause, making sure that you're handling that correctly, and may even consider your own service so that when you do work, your customer does walk into the grocery store, then you can do something, vibrate the phone or display something or so on. Now, a few backgrounding tips. It all sounds like unicorns, but there are a few things that you need to keep in mind. So Bluetooth Low Energy itself will have some effect, but fairly little effect on the battery life. So even if you just range for beacons in the background, it will have a negligible effect on the battery, as you would expect, but it's not going to kill the device. And of course, you can consider adding a sleep time. So if you don't want to range every second, because you don't need that granularity, maybe it's every minute, just to see, okay, has someone walked into the store or this room yet? And what will kill your battery is if you range a lot and you're making expensive calls. So if I'm doing a lot of ranging for beacons, and every time I detect a beacon, I make a network call, or I do an expensive storage request, well then the phone's going to run really hot in people's pockets, and your app is probably not going to be in favor. So ultimately, lots of things that you can do in the background, but with great power comes great responsibility. And we walk through the demo there. So where I wanted to end this is looking at some better accuracy in terms of indoor location. So having beacons set around an environment is really good. However, it really kind of limits yourself to particular zones. So with the device that's running here, I can say, well, I'm kind of close to here, and I'm kind of far away from here. But beyond that, it really doesn't give me much more. And we can start thinking about where a person might be in relation to a particular beacon. So if I have one beacon, let's say I've got a beacon here, configured with an ID and details that are getting picked up. If my phone is reporting that beacon is 10 feet away, then I could be anywhere in the circle. There's no compass on the beacon, there's nothing that's going to tell me where I am, but typically, as a developer, I can say, well, if I'm seeing a beacon 10 feet away, the user's probably there. That's interesting. Now let's add another beacon. And let's say we've got two beacons. And we say, okay, well, I can see two beacons, and they're both 10 feet away. Well, in that case, we can draw radiuses around the two beacons, and we can estimate that I'm either going to be at this point, or I'm going to be at this point, just because of the math there. Now, of course, you probably guessed what's coming up next. A third circle. So let's say we have three beacons that we can see in range. Well then, let's say that this one is 10 feet, and this one is 5 feet and 5 feet, just for mixing things up. Well, then I can extrapolate and predict that the user's probably going to be around this point. So kind of using the power ranges of the beacons to kind of identify where a particular person is in terms of space. And this concept is actually known as what's called trilateration. It's actually very similar to triangulation that you may have heard of with cell phones, except with triangulation you're actually using the angles to look at where a person is within 3 points. Trilateration actually uses these distances which can be equated from power ranges. Now, trilateration, of course, requires a minimum of 3 beacons, as you saw in the diagram. However, assuming relatively accurate power signals, and we'll talk about that in a minute, you can actually calculate a somewhat more accurate position rather than just, hey, I think you're in this region. So with that, probably going to turn to a demo here and see whether this works. So I got my iBeacon Explorer here, and it's got 2 beacons. I'm going to ask my esteemed colleague in the front to give us a third. So now we've got 3 beacons. That third beacon is 1.2. And as I wander around here, you can kind of see things changing. So what I'm doing in the code is something that I told you should not do. And every time I arrange for a beacon here, I am actually sending it to a network stack. Do not do this. And what I'm doing is I'm saying, well, look, if I have, I look at the beacons that are in sight and order them. And if I have more than 3, what I'm going to do is I'm going to construct a packet in JSON and take the device ID and then the major and minor for each of the beacons. And then I'm going to send it to a server. The server is running here. So that server is a running node in the background. And what it's doing is it's just picking up these events from my device here. And let me just skip into the code. So once it's picked up an event, we kind of look at the actual beacons that are coming in, and kind of extrapolate the beacons here. And then what I've done, this is kind of a hack, but I've kind of hard located what's called Cartesian coordinates for the beacons. So imagining that a point in space of 0.0 over there, I kind of imagined, okay, this is kind of a I know probably 6.1 and 1.1 over there, just to get some overall accuracy of the beacons. And then what I'm doing is just a fairly simple trimaturation algorithm, so that I can create a radii from each of the 3 beacons, and then plot a particular point. And then once I actually have a point here, I'm using a WebSocket. So I've got a WebSocket that's just plotting out, okay, we think you're here. And over on here, I've got I can already tell this is not going to work. We've got a website here, which has also been served, so let me show you what this looks like. Ironically, this was working with no people in the room. Just want to keep that in mind. And it's fairly simple. It's just a web page that connects a WebSocket to my node instance. And every time I send, or every time it receives the updated one, it actually plots a point on a canvas, which is this yellow block that you see here, as well as just logging to the console. So let me see what I'm getting. I'm getting 5 minus 4, which is off the edge of the box. What I didn't, as I said, we'll talk about signal bouncing in a minute. So let me see if I can rescue this before falling to a backup. So there's quite a lot of you in the audience. So let's see if I can see what happens if I do this. Okay, there we go. So we may have to fiddle with that a bit more, but what it's doing is it's now actually plotting my location. You can see a black dot walking over here, and I have no idea where this dot is going to go when I go over to the stage. So probably off the edge of the box, I think. Dot. Let's go down to -4 now. Maybe I'll see if we can get it back on. There we go. Kind of walking around. Still walking around. And maybe we'll go back. So I think the coordinates are slightly wrong, but hopefully that gives you the at least some idea of what we're trying to do there. And let me see. I think I have. Here's one I created earlier. So here's one that I prepared earlier, just in case this demo wasn't quite as accurate as I thought. And this one just actually shows an office where we had this set up for another demo. And as you can kind of see, again, there's a level of accuracy there that's obviously not quite perfect. But you can kind of imagine maybe something like this in a retail store, where you're not going to get exactly where people are, but it's good enough to get kind of traffic patterns. Maybe, okay, well, we saw, let's say we're doing something like this at a conference like this. We can say, hey, you know what, all of the traffic came into this room. All of it went from the main expo hall to the toilets or something. You're going to see these patterns, and it kind of becomes interesting. What we've also got in the sample code, although it's I didn't show it for today, is also the ability to store all of these coordinates in a backend storage database. So I'm using something called Mongoose, which you may have heard of. It's the connector for MongoDB. So every time we receive a coordinate here, assuming that code was uncommented, it would store it into a Mongo database. And then what we've got kind of running on the back end in another version of this in the office is a procedure or an ETL job that basically takes a bunch of Mongo data and then puts it in HDFS under a Hadoop instance. So then we can actually start doing some interesting data mining from it. So looking at different patterns and saying, okay, well, why do most people kind of go this way or into these particular areas? So what did we see? Well, I kind of saw this calculated position of three more than three beacons, but typically in this demo, 3 beacons sent to a Node backend. Obviously, with Node, we had to tell it where the positions of the beacons were. And in fact, for another version of this we are developing, we're actually, instead of a yellow box, which is of course only so useful, actually using a floor plan. Where you can then actually go into the floor plan and position each beacon. So say, okay, I've got a beacon in this corner of the room, beacon in this corner of the room. And then, of course, once the Node server picks that up and works out where that coordinate is, we're actually just using a WebSocket to broadcast that to whoever listens. And then we had that page with the yellow box that was responding to the WebSocket events and plotting the position on a particular canvas. Now, as you probably saw from my gallivanting around on stage, this is not perfect, and it really does depend on the environment. So if you think that you're going to design an app that's going to give you like inch perfect precision or even foot perfect precision of where a person is, that's really not the case. What we found in a lot of our testing is that walls are the iBeacon's worst enemy. And or line of sight obstructions. So iBeacons, in fact, Bluetooth LE works on a 2.4 gig spectrum. So that's the same frequency that those old not landline, but the old kind of wireless phones used to work with, which is great for picking up a signal around the house. Except with walls and things, you get a lot of signal noise and signal bouncing, and especially when you're trying to do triangulation with three particular points, then very, very frequently you get another signal that happens to be coming from a wall. So typically walls are enemies. So wherever possible, and this is a difficult room, but wherever possible you can get a line of sight that is unobstructed is going to give you your best signal. So for example, if this was a retail store, we may have like a false ceiling here, and then we could put like an array of iBeacons in a particular matrix and have a relatively better distance. In an open area, such as a retail store like that, we're seeing about 1 to 2 meters accuracy. So again, not super perfect, but certainly in terms of a large department store or a large warehouse or a museum, certainly good enough for seeing, okay, where is a person in relation to either products or statues or other things that might be indoors. So I'm going to wrap up. I know there's probably a lot of questions and want to make sure there's time in the end here. So obviously we've spent a lot of time this morning speaking about iBeacons. Hopefully from the takeaways from this is, yes, it's an Apple standard and will continue to be one. I'm sure Apple will rev the standard going forward. However, it is supported well on most of the latest devices. So certainly good support on iOS, But even on Android, as people start moving from Gingerbread to 4.3 upwards, I think that becomes a lot more appealing. What I would say is also, I think for a lot of the scenarios that we've certainly seen in the US, it's answered the question of what's happening to NFC. So as you may know, I think Google and Android, the team got pretty far behind NFC. They backed it. It was in very early, and it really never took off. Certainly in the US. And I think that there were a number of factors on this. One of which was the carriers in the US were trying to figure out how to make money from it. And as a result, until they figured out how to make money from it, they actually locked down the pervasive of this. So you could go in and buy like a Galaxy S, I think I had a Galaxy Nexus 4 and S3 back in the day, and it would have the NFC chip on it, and it would have the NFC support in API 14, but you couldn't use it because AT&T or whoever carrier it may have been had actually locked it out. And as a result, I think the world's passed us by, and now we'll see where it goes. Coming back to iBeacons, obviously we've shown a mix of hardware and software. So yes, you can buy custom hardware for fairly cheap, but if you're also looking to play around with this, and you have an iPhone or a Mac, or even an iPad, as long as it's got Bluetooth LE support, you can set that up as a beacon as well. So fairly simply, if you've got an iPhone and a Mac, you can use this as a beacon, and you'd have to walk around with your Mac, but you'd at least get the experience of what this is like. And I think more importantly, it's the whole range of iBeacons is kind of opening up quite a wide range of scenarios. So I think we're probably just scratching the surface of what can be done here. Not only retail and products, but I think a bunch of other scenarios that we probably even haven't thought of once you can predict and once you can know where people are indoors. So with that, I would like to thank you. I think we've got about just over 10 minutes for questions. What I did want to do is leave you with some links. So that's my website there, and also my Twitter handle. If you want the code that is shown here, you can find it on that GitHub address, which I'm sure Brent will be very fond of. And then if you want the slides, I uploaded the slides this morning to slideshare.net. So with that, open it up for any questions. All right, okay. First one, blue shirts.
We have seen a lot of manufacturers for that beacons, right? Is there any standard beacon coming up, or everybody has their own protocol sending it?
So the question was there any standard? So the actual wire standard, the protocol is somewhat standard. So if you go to Apple today, you've got to sign the NDA, but the actual specification it's fairly simple. But everyone when you sign the NDA with Apple, not only will they give you like the PDF of the specification, but then they will also give you the permission to use the iBeacon name and the iBeacon logo, like probably as a logo. So if you see a hardware vendor that claims they are iBeacon compatible and they've signed this NDA, it should be a fairly standard spec. With that said, there are people extending it already. Estimote, they have an SDK, and not only will they give you, or you'll be able to obtain the ID and the major and minor, but you'll also be able to obtain a bunch of other data from the Estimote, which is not in the specification. But in terms of core location, I think it's pretty standard.
So one more follow-up question.
Okay.
So when you say like Estimote that everybody has coming with their own SDK, so can't these, if the standard is set, can't these SDKs cross-talk to each other? For example, can a set of indoor location map use Estimotes, and can a set of they can, or you know?
Yeah, it's a good question. So in general, yes. Providing so the SDK will probably give you the core functionality that can work across anything. I think where the manufacturers are slightly different is some of these edge cases. So for example, this is a red glare beacon, they have a part of their SDK allows you to flash the beacon with a different ID and a different name, which actually we didn't talk about. There's an interesting security issue right there. But that particular protocol is very, very specific to red beacon, so you wouldn't be able to flash an estimate. And as I mentioned, estimate, I think you can get temperature and humidity in some of the later estimate devices, which you won't find in beacons. But yeah, in terms of core, okay, how many beacons are there? What's the range? You can either use what's in the base SDKs, or you can probably use the SDK from pretty much any vendor. Question down here?
Actually, I wanted to ask you how do you write your minor, major, and query information?
Okay. I may have already, yeah. So yes, so most of the beacon vendors will have an app. The Red Bear app is actually an iPhone app. I think they probably have an Android one as well. And then you basically just find the closest beacon, and then you can flash the UUID major and minor. And that stays through a power cycle as well. Now, of course, one of the things I should have mentioned inside is this certainly has the potential of interesting security. So if you had 1,000 of these iBeacons in an airport, people coming up with their phones and starting flashing beacons is probably not what you want. I know the Red Bear beacon is fairly basic. I think it's radius that have some level of either key, symmetric key that they're using in terms of flashing. But certainly looking forward, I'm pretty sure that vendors are going to put something on the phone or something on the devices that's going to lock down that. They're going to have to.
Is it the only information that you can write, or can it transfer some extra data also? For example, if I want to put the actual GPS coordination.
Yeah, good question. So today, those three pieces of information are the only ones that you can write. What we typically do when we're doing this for customers is we just have like a back-end lookup service where we pass it the ID, the major and minor, and then we get back a payload in JSON of, okay, this is the name, or as you said, this is the GPS coordinates, which would be a good one. So yeah, today you put it handle that in your own. Question here?
I would like to know about the use case of this particular concept towards retail store, as you were mentioning, because as you said, 1 to 2 meters is an accuracy point that you get. Now, in terms of when we look up at a retail store, what you ideally would be looking out is what for a particular item that you're looking for, and at which particular bay or a row it is being kept. So 1 to 2 meters is not fairly an accurate thing, from my perspective. So, to be very sure about, because it could be on say a row, a column B, or rather on the other side of it.
Right, exactly.
So those kind of things.
Yeah, it's a good question. So certainly the retail store is interesting, and as the gentleman mentioned, you can get this 1 to 2 meter accuracy. That's kind of where I think some of the trilateration can come in. So obviously, if I just have, let's say I've got, let's think of a retail category, shampoos. So I've got an aisle of shampoos. If I just put one beacon in the shampoo aisle, that might be good enough if I want to search for shampoos. But as you said, if I want to search for a particular brand or a particular item, you may be thinking that you're in the right aisle, but actually the beacon is like an aisle over. You're like, well, this is baked beans. What's going on? So kind of trilateration can help there, because then we could use 3 beacons. And again, it's going to vary on the environment, but we can probably put that down to a particular location. And then the other factor is also thinking about what the UI looks like for a retail app. So you're probably not going to give a user something that says, hey, you're half a meter away from the shampoo, and oh, now you're 1 meter away, now you're 3.25. And you're probably going to say, okay, shampoo is so far, and then probably a picture of the aisle, or maybe a map.
Also combined to augmented reality, combining both together.
Yeah, that's actually an interesting thing. I mean, the AR space, I could probably do another hour on this, is interesting. I think once you combine those indoor locations and AR is interesting. I'm not sure about India, but I think there's still a lot of social caution about AR today. So wandering around with a device like this in a store is probably going to get you thrown out. Now, of course, with glass, that might change a lot of that. But you're right. I think equally having something that combines the both even opens up some really interesting possibilities. Any more questions?
Yes. One question. So, let's say I have taken an app and I have put a beacon device on my door just to remind me once I was get out of my like a key or something like that. And that beacon gets damaged somehow. So in that case, what I do beacon, what I have to do is that I need to kind of register that I do.
Yeah, so let me see if I can paraphrase that. So you have a beacon, let's say at home or something, and let's say the scenario is as soon as I arrive home, it turns on the light. So you have a beacon. Once the device detects the beacon's in range, then it sends a REST service call to my home automation system that turns on the lights, isn't it, magic? And then you're saying, okay, if the beacon is
and I have to buy a new one and install it.
okay. Oh yeah, so good question. So if you buy a new beacon and you want to replace it, then all you would need to do is flash the new beacon with the same UUID, the same major and the same minor, so the same signature essentially, and then you could just replace it.
So in my app, I have to provide a facility that if you are buying a new beacon, then you have to first thing called kind of register that beacon.
Yeah, so if you were providing like a consumer app where people were installing their own beacons, then you would probably want some way of flashing those beacons as well, in probably a more user-friendly way. So you could probably say, I don't know, you could, if it was a home automation system, you could send them the beacon, and then just like setting up an alarm system or something, you could say, there you go, I've got one unrecognized beacon in range. Where is it? Is it in the entryway or the bathroom or the kitchen? And then, okay, it's in the kitchen. Okay, now I'm set. And underneath the covers, what you're actually doing is you're setting the UUID, you're setting the major and minor. So kind of, I think, kind of similar to maybe setting up like a Wi-Fi hotspot, kind of having something like that. Question on that?
Yeah, now that I believe it's extension of Bluetooth, right?
Sorry, I think yes.
Bluetooth. So yeah, I'm in the first 5 minutes maybe. So going ahead, is there a possibility that it can behave like a Bluetooth sync or anything, and as well as a sync and a source? Like, can we read the information? Can it behave like a server? That's what I'm kind of interested in. Because as long as it's like pretty down, oblivion of the fact that where it is or what it's doing, it's okay, it's pretty good. But then that's already there. And given the fact that advent of 802.11 Wi-Fi Direct and other things which is like more powerful and more efficient than Bluetooth 4 that's out in the market today. So is there a possibility that, that it has a set of APIs, I'm pretty sure. Is there a possibility that can be upgraded to support the source aspect as well, along with the sync?
That's a good question. So today, no, is the answer. So today it is literally just a dumb device running on Bluetooth LE. There's no interaction with it. You can't send things to it. You can't, apart from flashing the device, you really can't do anything with it. It really is, I don't want to call it a dumb device, but it is. Now there are possibilities that spec changes, the spec changes, and of course you can still interact with other Bluetooth devices if it doesn't lock you down. But primarily, the iBeacon spec is to make indoor proximity as simple as possible.
What I understand is what that would do is that would kind of cut off the overhead that the device would be getting for the server, like based on the beacon ID, I would get some information. That would cut off that kind of overhead. We can call it the server or the application database or whatever it is. If that can become a little smart generically.
Correct. So, yeah, you're right. I mean, if the spec was open in terms of if this thing knew what was connecting to it, then you're right. It could act as a relay and it could do more. However, today, I mean, the mode is this is just an emitter. There's nothing that it takes. And if you want to do anything like a name lookup or a check-in or registration, then it really needs to be piggybacked onto the device. And it's a little similar to I think how we've seen kind of Bluetooth evolve in the car. So a lot of the older Bluetooth kind of solutions were fairly dumb as well. It was like, okay, I can pair and I can play music. That's pretty much it. Now, if you start to see where Bluetooth is going in the car now, then it becomes, I think, much more similar to the scenario that we see. So yeah, good question. Chris?
My question is around UUID. You mentioned that actually those vehicles might have the same UUID, but traditionally, for me, I understand the need for that to have a business to have X number of vehicles to have something same identifier. But the use of term UUID to me seems misuse.
Right.
So I just wanted to know your thoughts on that.
Yes, that's a good one. So in fact, for that question, you get a free copy of my book. And it's the last question. So actually, a good question. So yes, UUID. And in fact, when we first started playing with the spec itself, we were like, oh, we just set all of these things on a different UUID, and nothing worked. And it's like, yeah, this is kind of weird. So it is strange, and in fact, other people have asked, well, why is it even a UUID? Why isn't it just like a reverse domain name or something other that we've used in the past, or I don't know, like an IPv6 thing? And it kind of is what it is. The origins come from something called NSUUID, which is the UUID object in NetStep, which is Apple's underlying thing. And it's kind of weird. In the API, they do call it a proximity UUID, which you can kind of say, okay, this is a group. But ultimately, the goal is, okay, if multiple companies, let's take an airport, for example, which I think this is going to be prevalent on. If multiple companies are doing multiple beacons around that airport, if you can see every beacon, it's going to be kind of crazy. So it's really just maybe they should have called it a partition UUID, really a way of partitioning a group of beacons so that they can do something. But yeah, good question. And come through at the end, I'll send you a copy. So I think with that, I think we're done. I again like to thank you for your time, and my contact details are on there in case you have any questions. Thank you.